So welcome back to this video on removal of left recursion. So we are going to look at the algorithm for doing this. And as we have already seen in our previous lecture that for a simple case of left recursion, of immediate left recursion, we can replace it by two productions so that the grammar remains intact, but the production rule changes and we don't have any more left recursion. So let us look at the formal algorithm for doing this here. So the algorithm is like this. So first of all, we have to choose an ordering of all the non-terminals of the language. So I have to order them in you can pick any order you want. So it is in the, we'll call the non-terminals as A1, A2 up to AM. So if we have M non-terminals, then I'm going to order them A1, A2 up to AM. Then we have two loops in the algorithm. So the outer loop loops through all the non-terminal symbols for I going from 1 to M. And in the inner loop, we are looping through all the non-terminals again, but starting from 1 to the currently the non-terminal that we are looking in the current iteration. So what we are doing here is for I going from 1 to M, and in the inner loop for j going from 1 to I minus 1, what we will do, we'll look at the terminals, we'll look at the productions as AI derives AJ beta. Okay, so if we have a production like this, then we are going to replace this production by the rule AI derives alpha 1 beta, alpha 2 beta, and so on up to alpha k beta, where for this AI variable, we have to have some productions of this type. AI derives alpha 1 or alpha 2 or up to alpha k, where this is the current rule for your J. So I think I have a small mistake here. This should be, instead of AI, this should be AJ. So where AJ derives alpha 1, alpha 2 up to alpha k. So we'll replace AI derives AJ by beta. That means basically what we're doing is we are replacing the variable AJ with its productions. So alpha AJ would be first instance here would be replaced by alpha 1 beta because AJ derives alpha 1, then alpha 2 beta, and so on up to alpha k beta. So this production would be replaced by this production. Okay, so this is the algorithm. So let's look at this example. So here I have a grammar, and what we are going to do is we are going to use our algorithm to remove the left recursion here. So let me order the variables like this. So I have the non-terminals I have are A and B. So I can give any ordering I want, but let me put A1 and A2. So A is A1 and B is A2. So A1 comes before A2. A comes before B. So I have two now. Since I have two variables, so M here is equal to 2. So my outer loop in my algorithm is going to execute 2 times. So for the first iteration, I is equal to 1. So that means now I'm considering the production starting with A, starting from A. So production starting with A is A derives BA, AC, and C. But the inner loop, J loop, starts from 1 to I minus 1. So this outer loop, inner loop does not execute here because I is equal to 1. So the inner loop doesn't execute. So here only thing that we are going to do is we are going to remove the immediate left recursion of the non-terminal A. So we'll do it like this. How we had done it before, we'll replace it by this as BA A dash k, then c a dash, and a dash derives a dash and or epsilon. Okay, so we have removed the immediate left recursion of a. It was because of this. Then the B production remains as it is. B, B, A, B, and D. Okay, so now I have completed the first iteration of the inner loop as well as the outer loop. Now inner loop doesn't execute, so only the outer loop. Next we will take I is equal to 2. So for I is equal to 2, the this is I is equal to 2, so the inner loop out will execute one time, exactly once. So with j is equal to 1. So with j is equal to 1, so in this case we will eliminate the recursion, this particular production. Okay, so we will replace, this is our ai and this is our aj and b is our beta. So we will replace aj by its production. So if I have productions of this type, alpha 1, alpha 2, alpha k, then I'm going to replace this by, this is going to be replaced by ai derives alpha 1 beta, alpha 2 beta, alpha k beta. So our production is this, b derives ab. So we will replace this with b derives b a dash b, c a dash b, or d. Right? Why? Because our aj productions was like this. What was the alpha 1? Alpha 1, we had alpha 1, we had b a dash or c a dash. So this was our alpha 1, this was our alpha 2. So we put this alpha 1 here, and this was our beta, and again this was our alpha 1, this was our beta. Of course this one may not, it need not appear. So we have our new production like this. So if we put it now all together, we will get something like this. A derives b a dash or c a dash derives a dash or epsilon, b derives, now b also had its own b production, b, then the new productions that we added, b a dash b, c a dash b, and we have added the d production was there, so here we have it. Now so you can see now that there's only now two more left recursions remaining, that is on b, this and this. So this again we will remove the immediate left recursion on b. So to do that we will replace, I'm only going to write this one. Okay, I'm only going to rewrite this. The first two production remains as it is. So this is 1, this is 2. This has to be modified, so we will modify it like this. B derives C A dash B, B dash, and D B dash, and B dash derives B B dash, okay, A A dash B, B dash, or epsilon. Okay, so here we have our production. So now this is going to be our production number 3. So if we look at 1, 2 and 3, we'll see that with none of these have the left recursion anywhere, either directly or indirectly. So our initial grammar was this. So there were two types of recursion. One was immediate, A derives AA, this was immediate left recursion. B derives BB, this was also immediate left recursion. Also we had from B we had B derives AB, this was a indirect left recursion. Similarly from A also we had A derives BA, this was also an immediate sorry, not an immediate, this is also an indirect left recursion. So now after doing this, you see that after doing this we are left with these 1, 2 and 3, these productions, and none of these they have left recursion, either direct, that is immediate, or indirect. So we can